So welcome to all of you. Now we go to the chapter 3rd, that is the limit. So before that we'll see the function and their graphs. Okay. So first we will say the what do you mean by a function. So definition of function is what? A relation. So function is the first, it is a relation. Here from A to B. So we have you have seen in the algebra. Okay. So we have seen in the first chapter of the algebra, that is a relation. So a relation f from A to B is called a function if every element of A is related to B, then we say that it is a function. Every element of A related to unique element of B, then that is a function. Okay. So we are familiar with the function. So A is called the domain of the function and B is called the codomain of the function. Okay. So what do you mean by range of the function? So if f from A to B is a function, okay, then the set f of x is equal to x belong to A. So set of all images is called a range of the f. Okay. So now suppose we have defined some f of x is equal to 1 upon twice x like this. So the domain is not specified here. So we have to assume that your domain is the set of the real number, and this is called the set R. The set of the real number is called as a natural domain. Okay. So that means if you define f of x is equal to 1 upon twice x plus 3. So now here domain is not mentioned. So you have to assume that the domain is the set of the real number. Okay. And so the domain of the domain is what? The set of the real number. So now we will see what do we mean by actually the range and the function with the help of the Venn diagram now. So now suppose A is this set and B is the set here 1, 2, 3, 4, 5 something like A, B, C, D, E. Now this relation will mention here now here. Suppose this is a relation. Is it a function? Now see, every element of A is related to one and only element of B. So this is a function. 1 is related to only A. 2 is related to only one element. Whatever this may be, images are not here. So what they should have the unique image. 1 is related to only one element. See, 1 is related to A, 2 is related to A only, right? So that means 2 is related to only one element of this one. So what are the images? This is not important here. So now this is a function now. Okay, what is the domain of this function is one? Domain is A now. Domain is A. Codomain is B. So what is the range now? Range. So range means what? It is a subset of the codomain. So just see the codomain. So which has the pre-image? So which has the pre-image? A has pre-image. B has. C don't have the pre-image. So it will not in the domain. Okay. So now this is your range now. So range means what? It is a subset of the codomain which has the at least one pre-image in A. The elements of B which has at least one. Why it is at least one? Because A has two pre-images. So now we C don't have the image. That means C is not in the range. D is not in the range now. So range set means what? It is the subset of the codomain which has the pre-image in A now. Okay. So that is your range. So now we'll see some problems. What is the domain now? For domain and codomain of the function now here. So we'll find the domain of the function. Okay, so we'll take a example. Find the natural domain. Whatever this natural or simply the natural simply the domain of the following functions. 1. F of x is equal to 1 upon x minus 3. Second, f of x is equal to x square plus 2. Third, f of x is equal to root of 1 plus 6x. Fourth one, f of x is equal to root of 1 minus x square. And the fourth one, fifth one, f of x is equal to root of x minus 2. Okay, you have to find the domain. Domain means what? So see, this is the domain, and so whatever this domain here, what? Every element should have the image. So now this is the set of R real number is given to you. So we want to find a domain which is the subset of R such way that every element have the image in under this formula. Under this formula. So one solution of one f of x. This is the given relation actually. So now this is when it is defined. When it is defined, so it is defined if x minus 3 not equal to 0. So that means if x minus 3 is not equal to 0, then this is well defined. So now the domain, so this is when it is not defined, so that is x not equal to 3. So if x not equal to 3, then at every point this is defined. So your domain is what? So domain is nothing but set of the R minus singleton. Or you may write this what? X belongs to R such that x not equal to 3. X is a real number such that x not equal to 3. This is the domain. Okay. So if x not equal to 3, only 3 has no image. Only 3 has no image in the codomain. So therefore we have punctured this side. We have to puncture this side. We have removed the 3 from the this domain. So 3 from this, remove this 3 from, it will be your domain now. Okay. So if you remove 3 from the set of the real number, then all the elements of this R have the image in the codomain. So that means what? It is the domain of, domain is what? Just R minus 3. Okay. Now we'll take the second one. We'll take the second one. F of x is equal to x square plus 2. So now what? F of x is defined. Every value of x belongs to R. For every real number, it is well defined, no problem for this. So therefore, domain of is equal to the set of all the real number. Okay. So now the problem is over. Only you have to find the domain of this one. Okay. So that means what? Whatever the R, you have to find the domain is what? You have to find the possible values of x. You have to find the possible values of x. That means you have to specify x. Specify the values of the x only. Now we will take the third one now. Okay. So third one. F of x is equal to root of 1 plus 6x. So now the root of the real number is real number if and only the whatever the, so what is what? X is real number. Right? When it will be real number? If and only x is greater than 0. Root x is a real number if and only, that means what? When root is exist, if it is x is positive. Okay. So when f of x is defined, so what? F of x is defined. F of x is defined if 1 plus 6x is greater than or equal to 0. So we'll shift 1 to that side. X greater than or equal to minus 1. So x is greater than minus 1 upon 6. So what is your domain? So domain of f is equal to x belongs to R such that x is greater than or equal to minus 1 by 6. Minus 1 by 6. Okay. If you want to write in the interval form, so see this is what? Minus 1 by 6 here. Now x is greater than minus 1 by 6. That means you are here. So you can write this is what? This is infinity. This is minus infinity. You can write in the form of the interval also. In the form of the interval. Minus 1 by 6 infinity. Right? So if you won't write this, then don't write this. Okay? So just write this one. Okay? X. Okay? So now we'll take the next one. F of x is equal to 1 minus x square. 1 minus x square. Again f of x is defined. F of x is defined if 1 minus x square is greater than or equal to 0. 1 minus x square is greater than 0. So that is what? 1 is greater than or equal to x square. That is what? X square is less than or equal to 1. So what does this imply then? Minus 1 less than or equal to x less than or equal to 1. Okay. So that means what? Your domain of f is equal to x belongs to R such that minus 1 less than or equal to this. Only these possible values. If you take the other value which is not lies between minus 1 and 1, now see your root will be the negative now. Whatever the number under the root will be the negative now. Okay. So this is what you can write in the interval form also. This is the closed interval minus 1 1. If it is strictly not strictly now here because it is greater than or equal to 0. For 0 root of 0 is 0. So no problem this one. Okay. So now this is your domain now. Okay. So now we'll take the last one, that is for f of x is equal to root of x minus 2. Okay. So f of x is defined if it is well defined if x minus 2 is greater than or equal to 0. So x is greater than or equal to 2. So therefore your domain is what then? Domain of f is equal to x belongs to R such that x is greater than or equal to 2. If you want to write, this is what now 2 is here and infinity is here. X is greater than 2. So 2 will be here. That means if you want to write the interval form, you can write this like this. Okay. So to infinity. So I hope that you understand how to find the domain of the function. Okay. Now we'll see how to find the range of the function. How to find the range of the function. So range of the function. Okay, so we'll step 1. Step 1. How to find the range of the function? We'll write the steps for this one. Put y is equal to f of x. Whatever it is given, put y is equal to f of x. Step second. Solve x in terms of, that means write x in terms of y. X is equal to, so this is what y is equal to in terms of x. Just write x in terms of y now. Okay. Now step third is what? The range of f. The range of f is the set of all real numbers y such that x can be solved. X can be solved. Okay. So remember this. These are the steps. Okay. So we'll take a problem so that you will understand how to follow these steps now. How to follow these steps. Okay. We'll take a problem. Okay. Find a range of each of the following functions. 1. F of x is equal to x square plus 2. Second, f of x is equal to 1 upon x minus 3. Previously we got the domain of this one. Okay. So third one, root of 1 plus 6x. F of x is equal to 4th one, f of x is equal to root of 1 minus x1. Okay. So we have to find the range of this function. Okay. Solution of 1. Let y is equal to f of x is equal to x square plus 2. Okay. So now we have to solve this in terms of x now. Okay. So y is equal to what? X square plus 2. So therefore x square is equal to what? Y minus 2 now. Okay. So x is equal to what then? Plus or minus root of y minus 2. Plus or minus y minus 2. Okay. So when it is solvable, x can be solved only if and only if y minus 2 is greater than 0. So your range is what? your range is equal to what? So y belongs to R such that y is greater than or equal to 2. This is your range now. So range means what? We have to write actually y is equal to f of x now. F of x belongs to R such that f of x is greater than or equal to 2. So you can write in the interval form. So this is 2 to infinity. Okay, range. Next, second. Let y is equal to f of x is equal to 1 upon x minus 3. Okay, so we write 1 upon y now. 1 upon y is equal to 1 upon y is equal to x minus 3. X minus 3. So x is equal to 1 upon y plus 3. Okay, x can be solved. X can be solved if and only if and only y not equal to 0. Because if y is equal to 0, then it is undefined. Your x will be undefined. So therefore range is equal to y belongs to R such that y not equal to 0. You may write this is what? R minus singleton 0. So what here? 1 upon y is there. Right? If y is 0, then it is undefined. That means x is solvable if y not equal to 0. Okay? So now third one. But let y is equal to f of x is equal to root of 1 plus 6x. So y square is equal to 1 plus 6x. Okay? So I show the 6x is equal to y square minus 1. Okay? So x is equal to y square minus 1 upon 6. Y square minus 1 6. Okay? X is solvable for all y belongs to R. For all y belongs to R. Because what your denominator is 6 now here. Okay? So that means your range is equal to y belongs to R. Y belongs to R. There is no restriction on y. There is no restriction on y. So now here what? Y should be the greater than equal to 0. Okay? So y greater than equal to 0. Y belongs to R such that y is greater than equal to 0. Now we'll take the last one now. Because we have taken the positive root. So therefore y is equal to f of x is equal to root of 1 plus x square. Okay? So y greater than equal to 0 is there. Okay? So 1 plus x square is equal to y square. So x square is equal to y square minus 1. Okay? So x is equal to plus or minus root of y square minus 1. So x is solvable if and only if y square minus 1 is greater than equal to 0. So if and only if y square minus 1 is greater than equal to 0. Right? So that means what? Y square is greater than equal to 1. Okay? So 1 is less than y square. 1 is less than y square. That means what? Minus 1 less than equal to y? Less than 1. Less than 1. Okay? But y is positive. But y is positive. Therefore, this implies that minus 1 less than y less than 1. Okay? So therefore range is equal to y belongs to R such that 0 less than equal to y less than or equal to 1. So this is closed interval 0 1. Closed interval 0 1. Okay? So just we got this one. Okay? Remember this is root, it is positive, it is not plus or minus. So therefore y is greater than 0. Okay? So if there is plus or minus, then problem arise, because what, element x has two images then, and if x has two images, it will be not a function. So I have to take the y as greater than or equal to 0. Okay. So if it is minus, then y will be less than 0. Okay. So in this way you can find the range and domain of the function. So range and domain of the function. Okay. So we'll take one more problem. Find the domain of the function f of x is equal to root of x plus 7 minus root of x square plus twice x minus 15. Okay. Solution. Given that f of x is equal to root of x plus 7 minus root of x square plus twice x minus 15. Okay. So f of x is defined if and only if x plus 7 is greater than or equal to 0 and x square plus twice x minus 15 is greater than or equal to 0. This is the condition. What does this implies? X plus 7 is greater than or equal to 0, and you can factorize this. So the product is minus 15, and sum is 2. The sum is 2 now. So these numbers are 5 and 3. So this is what, plus 5 minus 3 now. Plus 5 minus 3 now. So this is what then, x plus 5, x minus 3 is greater than 0. This implies that x plus 7 is greater than or equal to 0, and we will solve this one. So x plus 5 is greater than or equal to 0, x minus 3 and x minus 3 greater than or equal to, or x plus 5 less than 0 and x minus 3 less than 0. Okay. So this implies that x plus 7 greater than or equal to 0, and first we will solve this one. So x is greater than minus 5 and x is greater than 3, or x is less than minus 5 and x is less than or equal to 3. Now your minus 5 here, your 3 is here. What this says? X is greater than minus 5. X is greater than minus 5. And this says x is greater than 3. X is greater than 3. So it is enough to say that x is greater than 3. So this implies that x is greater than or equal to minus 7. And this is what, from this one you will simply say that x is greater than or equal to 3. Or what do this x is less than minus 5 and x less than 3, it is simply say that x is less than or equal to minus 5. Okay. Now here what, p and q or r. So this is nothing but p and q or p and r. Okay. So we know that. So this implies that x is greater than or equal to minus 7 and x is greater than or equal to 3, or x is greater than minus 7 and x is less than minus 5 and x is less than minus 5. Okay. So what does this imply again? See, this is what, minus 7 and 3 now here. Okay. So now here what? So your minus 7 is here and your 3 is here. What it says? X is greater than minus 7. What it says? X is greater than 3. So it is enough to say that x is greater than 3. X is greater than or equal to 3. Or here what? X is less than, this is what here? Minus 7 and minus 5. This is minus 7, minus 5 here. What is said? X is greater than minus 7. What is said? X is less than minus 5. So, or this is what then? Minus 7 less than or equal to x less than or equal to minus 5. So, your domain is what then? Domain x belongs to R such that x is greater than equal to 3 or minus 7 less than equal to x less than equal to 5. If you want to write in terms of interval, so what we will write this? See, x is 3 here, minus infinity is here. Okay, so that is what it is closed now here, 3 to infinity, open now, union. Now this is what minus 7, this is minus 5. Okay, so minus 7, minus 5. This is in terms of the set now. Okay, if you are, it is not possible for you to write this one, don't write this one. Keep as this is what, keep this as it is now. Okay, so it will be the domain. It will be your domain now. Okay. Now we'll take find next instead of this. Find the range of the function f of x is equal to twice x plus 1 upon x square plus 1. Okay, solution. Let y is equal to f of x is equal to twice x plus 1 upon x square plus 1. Okay, so now we have to solve this x in terms of y now. Okay, so this is what then y into x square plus 1 is equal to twice x plus 1. This is what y square plus y plus twice x minus twice x. It is what? Minus twice x minus 1 is equal to 0. So this is what then y x square minus twice x plus y minus 1 is equal to 0. This is a quadratic in x. This is the quadratic in x. So x is equal to minus b. So this is 2 plus or minus root of b square minus 4ac minus 4ac minus 1. This is minus 1. Okay. B minus b plus or minus root of b square minus 4ac. You know that this is the quadratic equation. Then the roots of these equations are minus b. So b square minus 4ac upon twice a. Yeah? What is b? The coefficient of x is minus 2 here. So minus b. So this is 2. Then b square is what? 2 square is 4 minus 4. Your a is what? Coefficient of x square is. And your constant, the term which not contain x. So term not contain x is this. Minus 1. Upon twice a. So upon twice y. Okay. So x is equal to. So this is what? 2 plus or minus 2 root of. So I can write this is 1 minus. So I can take the 4 outside. Okay. So minus y square plus y upon twice y. Upon twice y. So this is what then x is equal to 1 plus or minus root of 1 plus y minus y square upon y. Okay. So x is solvable if and only if y is greater than 0. Y not equal to 0. And 1 plus y minus y square is greater than or equal to 0. Greater than or equal to 0. So not y, y not equal to 0. Y whatever is positive or negative, it is not affected. If I look y not equal to 0 and 1 plus y. Okay. So we make a y square as positive. So this is what? Y square minus 1 less than 0. What is it? We will make it this as a positive. So what is this? So we will solve this here now. We will solve this here now. Okay. So now y square minus y minus 1 is equal to 0. This implies that. How we can factorize this? Okay, we will find the roots of this one. So 1 plus or minus root of b square. B square is 1 minus 4ac. So plus 4 upon twice a is 2 now. So this is what? 1 plus or minus root 5 upon 2. Okay. So that means what here? We can factorize this is what? Y minus 1 plus root 5 upon 2 y minus 1 minus root 5 upon 2. This is less than or equal to 0. This is less than or equal to 0. Okay. So that means what here? This implies that y belongs to which one is the less? 1 minus root 5 upon 2, 1 plus root 5 upon 2. This will be your y. Okay. So possible values of y are this, and that is your range now. See, this is less than 0. These are the factor of this one. You may check this one. Okay. So range is equal to 1 minus root 5 upon 2, 1 plus root 5 upon 2. Now see, 0 is not there. 0 is not included here. So I hope that you understand this one, how to find the range of the function and domain of the function. Okay. So now this is the end of the first point, that is the range and domain of the function. Okay. In the next time we'll see the types of the function and how to plot the that graph of that function. Okay. So now we'll stop here. Thank you.